Galileo Galilei was born on February 15, 1564, in the city of Pisa, which was then part of the Duchy of Florence, Italy. He was the firstborn son of Vincenzo Galilei, a musician and a scholar, and Giulia Amenati. The family was relatively well off, and Galileo grew up in a household where intellectual pursuits were valued. From an early age, he showed a keen interest in learning, though it was initially directed toward the arts and humanities, which was typical of his era's education for young men of his social class. In 1581, at the age of 17, Galileo enrolled at the University of Pisa to study medicine. His father, who was concerned with Galileo's future and the family's financial stability, hoped his son would become a doctor. However, during his time at university, Galileo developed a strong passion for mathematics and natural philosophy, the precursor to modern science. He found himself increasingly drawn to the study of motion, geometry, and the works of the ancient Greek philosophers, especially Euclid and Archimedes. Galileo's growing fascination with mathematics led him to abandon his initial focus on medicine, despite the pressure to follow his father's wishes. During his university years, Galileo faced some academic challenges. He was not always a standout student, and he even failed a few exams. However, his talent in mathematics became undeniable. After completing his studies at the University of Pisa in 1585, Galileo took a brief teaching position at the same university, where he began to lecture on mathematics. This experience marked the beginning of his career as an educator and an academic. His early lectures, though not widely popular, were well regarded by those who attended. He demonstrated a unique ability to connect complex mathematical concepts with real-world observations. By the late 1580s, Galileo's intellectual curiosity began to move him toward a more experimental approach to science, which was quite innovative for the time. He started to challenge existing scientific theories and became more critical of the traditional Aristotelian views that dominated the academic world. This period marked the start of his journey toward becoming one of the most revolutionary figures in the history of science, laying the groundwork for his future discoveries. In 1609, Galileo Galilei encountered a device that would change the course of scientific history: the telescope. The device had already been invented in the Netherlands by Hans Lippershey, but it was still a relatively new and limited tool. When Galileo heard of this innovation, he saw its potential immediately and began to improve upon the original design. He was not content with the simple magnification offered by the initial version, and through his own meticulous work, he managed to create a telescope that was much more powerful and capable of magnifying objects up to 30 times their original size. Galileo's work on the telescope was not just about improving its magnifying capabilities. He also wanted to refine the lenses and the overall design to make it more practical for detailed observation. His telescope, with its sharper focus and increased clarity, soon allowed him to explore the heavens in ways that had never been possible before. Galileo's ability to craft precise lenses and his understanding of optics were essential in transforming the telescope from a simple curiosity into a serious scientific instrument. By the summer of 1609, Galileo had made enough progress on the device to start using it for astronomical observations. The impact of this momentous step cannot be overstated. For the first time, humans were able to observe distant celestial bodies with unprecedented detail. Galileo trained his improved telescope on the night sky and made groundbreaking discoveries that would forever alter our understanding of the cosmos. Among his most notable findings was his observation of the moon's surface. With his telescope, Galileo saw that the moon was not a smooth, perfect sphere as previously thought, but was instead rugged and uneven, covered with craters and mountains. He also turned his telescope toward Jupiter and discovered 4 moons orbiting the planet, what are now known as the Galilean moons, Io, Europa, Ganymede, and Callisto. This was a significant discovery because it provided strong evidence that not everything in the heavens orbited the Earth, as the geocentric model proposed. Galileo's improvements to the telescope and his subsequent observations of the night sky were revolutionary. His work shattered many long-held beliefs and played a crucial role in challenging the traditional view of the universe. The telescope became an indispensable tool in astronomy, and Galileo's innovations set the stage for future generations of scientists to further explore the mysteries of the universe. Between 1609 and 1610, Galileo made several profound astronomical discoveries that would reshape our understanding of the universe. His improvements to the telescope allowed him to observe celestial objects in much greater detail than ever before, revealing aspects of the cosmos that were previously invisible to the naked eye. These discoveries not only challenged the prevailing geocentric model, which held that the Earth was the center of the universe, but also set the stage for the eventual acceptance of the heliocentric theory proposed by Copernicus. One of Galileo's most significant findings was his detailed observation of the moon. He noticed that the moon's surface was not smooth and perfect, as was commonly believed by scholars at the time, but instead featured uneven terrain with mountains, valleys, and craters. This was a remarkable discovery, as it contradicted the prevailing Aristotelian belief that celestial bodies were immutable and perfect. Galileo's observations of the moon provided early evidence that the heavens were not as perfect as once thought, paving the way for the acceptance of imperfection in the natural world. In 1610, Galileo turned his telescope toward Jupiter, making another groundbreaking discovery. He observed that Jupiter had 4 large moons orbiting around it. These moons, Io, Europa, Ganymede, and Callisto, were unlike anything seen before and were later named the Galilean moons in his honor. The discovery of these moons was of immense importance because it demonstrated that not all celestial bodies orbited the Earth, directly challenging the geocentric model that placed the Earth at the center of the universe. It provided strong support for the heliocentric model, in which the Earth and other planets orbit the Sun, not the Earth being the center of everything. Another critical discovery was Galileo's observation of the phases of Venus. He noticed that Venus went through a full set of phases, similar to the phases of the Moon, from a thin crescent to a full disk. This observation strongly supported the heliocentric theory, because in the geocentric model, Venus would not be able to display the full range of phases that Galileo observed. The fact that Venus exhibited these phases could only be explained if Venus orbited the Sun rather than the Earth. Additionally, Galileo made observations of the stars and their configurations. While many of the stars were beyond the resolution of his telescope, he noted that the Milky Way was made up of countless individual stars, not a nebulous cloud, as had been previously thought. This helped shift the understanding of the universe from a few fixed stars to a far more complex and vast expanse. Galileo's discoveries during this period were instrumental in challenging the long-standing views of the universe and directly contributed to the downfall of the geocentric model. His observations not only provided critical evidence supporting the heliocentric theory, but also laid the foundation for modern astronomy and physics, showcasing the importance of empirical observation and the scientific method in advancing knowledge. The conflict between Galileo Galilei and the Catholic Church began in earnest in 1616, when Galileo's support for the heliocentric model of the solar system, proposed by Copernicus, began to clash with the Church's official stance. At that time, the Catholic Church adhered to the geocentric model, which placed Earth at the center of the universe. a view that had been widely accepted since the teachings of Aristotle and Ptolemy. The heliocentric theory, which argued that the Earth and other planets orbited the Sun, was seen as heretical because it contradicted Scripture, particularly passages that were interpreted to suggest that the Earth was immovable and the center of the universe. In 1616, Galileo's findings, especially his observations of Jupiter's moons and the phases of Venus, provided strong evidence supporting the heliocentric theory. Galileo had been a vocal proponent of the Copernican model, and by this point his discoveries were challenging the Church's teachings. The Catholic Church, under the leadership of Pope Paul V, took action against the spread of Copernican ideas. The Church issued a decree in 1616 that declared the heliocentric model to be formally heretical because it appeared to contradict the Scriptures. Specifically, the Church pointed to verses such as Psalm 145, which said, "The earth is fixed and cannot be moved," as evidence that the earth must be stationary at the center of the universe. In response to the Church's condemnation, Galileo was ordered to abandon his public support for the Copernican system. Galileo, however, did not completely give up on his views. Instead, he became more cautious in how he presented the heliocentric model, presenting it as a mathematical hypothesis rather than a proven fact. He did, however, continue his research and observations. The tension escalated after Galileo published his book, Dialogue Concerning the Two Chief World Systems in 1632.pd. In this work, Galileo presented the heliocentric model as more plausible than the geocentric model. The book was structured as a debate between three characters: Salviati, the proponent of the heliocentric theory; Simplicio, a defender of the geocentric model; and Sagredo, a neutral character. Although Galileo did not directly attack the Church, he depicted Simplicio, the defender of the traditional view, in a way that many Church officials found ridiculing and disrespectful. The publication of the dialogue prompted a vigorous response from the Church. Galileo was summoned to Rome to face charges of heresy in 1633 AD. During his trial before the Roman Catholic Inquisition, Galileo was found guilty of vehement suspicion of heresy for teaching the heliocentric theory as fact. The Inquisition's verdict was harsh. Galileo was forced to publicly recant his views, and he was found guilty of teaching a theory that contradicted Scripture. As a result, he was sentenced to house arrest for the remainder of his life. Despite this personal and professional setback, Galileo's ideas did not disappear. His work continued to influence later generations of scientists, and his contributions laid the foundation for modern physics and astronomy. The Church's condemnation of Galileo's work, however, marked one of the most significant clashes between science and religion in history. The Church eventually acknowledged its mistake, and in 1992, the Vatican formally removed the condemnation of Galileo, recognizing the importance of his scientific discoveries. Galileo's trial and the subsequent conflict with the Church were emblematic of the tensions between emerging scientific discoveries and established religious doctrines in the early modern period. Galileo's experience underscored the challenges faced by those who questioned long-held beliefs, but it also highlighted the resilience of scientific inquiry in the face of authority. Between 1610 and 1638, Galileo Galilei made groundbreaking contributions to science, solidifying his place as one of the most important figures in the history of science. During this period, Galileo not only advanced his discoveries, but also authored some of the most influential works that laid the groundwork for modern physics, astronomy, and the scientific method. His works combined careful observation, mathematical reasoning, and an experimental approach, transforming the way people understood the natural world. One of Galileo's most famous works during this period was Sidereus Nuncius, the Starry Messenger, published in 1610. In this book, Galileo presented his astronomical observations made through his improved telescope. Sidereus Nuncius was groundbreaking because it provided detailed accounts of his observations, which included the craters and mountains on the moon, the 4 moons of Jupiter, and countless stars that were previously invisible to the naked eye. The book was widely read and had an immediate impact on both the scientific community and the general public. It also established Galileo's reputation as a leader in the field of astronomy. His careful documentation of his findings and his method of using the telescope to study the heavens marked a major departure from previous methods that relied mostly on philosophical speculation and visual observation without the aid of instruments. In addition to Sidereus Nuncius, Galileo's 1632 work, Dialogue Concerning the Two Chief World Systems, further cemented his position as a leading figure in the scientific revolution. This book presented a clear and detailed comparison of the geocentric and heliocentric models of the universe. The dialogue was structured as a conversation between 3 characters: Salviati, who supported the heliocentric system, Simplicio, who represented the geocentric view, and Segredo, a neutral observer. Through the dialogue format, Galileo provided a compelling argument in favor of the heliocentric model, using the evidence from his own observations, such as the phases of Venus and the moons of Jupiter, to support his case. Although the book was written in a relatively accessible style, it was also deeply scientific, with Galileo's sharp reasoning and extensive use of empirical evidence, making it a significant intellectual work. Another crucial work from this period was Discourses and Mathematical Demonstrations Relating to Two New Sciences, published in 1638. This book represented the culmination of Galileo's studies in mechanics and the laws of motion. In it, he introduced foundational concepts of kinematics, including the idea that the motion of objects could be described mathematically. The book contains his discussions on the motion of bodies on inclined planes, the nature of falling objects, and the principle of inertia, which would later become central to Newtonian mechanics. While Discourses was written toward the end of Galileo's life and while he was under house arrest, it marked a critical turning point in the history of physics. Galileo's insistence on using experiments in mathematics to describe physical phenomena helped to establish the framework for modern experimental science. These works reflect Galileo's shift away from philosophical argumentation toward a focus on empirical data and mathematical descriptions of the natural world. His use of the scientific method, observing nature, forming hypotheses, experimenting, and analyzing results, was revolutionary for his time. Galileo's emphasis on mathematics as the language of science had a profound impact on the development of physics and astronomy. Even beyond these major works, Galileo's influence extended to numerous smaller papers and letters in which he discussed a wide variety of topics, including the motion of pendulums, the nature of light and color, and the study of tides. Throughout his writings, Galileo advocated for a new way of approaching scientific inquiry, one that relied on direct observation, experimentation, and mathematical reasoning, rather than on reliance on ancient texts and unquestioned authority. Galileo's work was also pivotal in shaping the future of scientific publishing. By making his findings widely accessible, he encouraged other scientists to adopt similar methods and pursue their own observations. His ability to combine theory with practice and his advocacy for the scientific method laid the groundwork for future scientific endeavors, including the work of later figures like Johannes Kepler and Isaac Newton. In summary, Galileo's contributions between 1610 and 1638 not only advanced the fields of astronomy and physics, but also introduced revolutionary ways of thinking about science. His works changed how we study and understand the universe, and his influence remains a cornerstone of modern scientific thought. Galileo Galilei passed away on January 8, 1642, at the age of 77. After a life marked by extraordinary scientific achievements, intense personal struggles, and a lasting impact on the course of scientific history, his death marked the end of an era, but his ideas, despite facing significant opposition during his lifetime, would continue to shape and influence generations of scientists and thinkers long after his passing. Galileo's legacy is not just in the revolutionary discoveries he made, but also in how he redefined the process of scientific inquiry. During his later years, Galileo spent much of his time in house arrest, imposed by the Catholic Church after his conviction in 1633 for advocating the heliocentric model. This sentence came after the publication of his book, Dialogue Concerning the Two Chief World Systems, which supported the idea that the Earth revolved around the Sun. Though his work was banned by the Church, and he was forced to recant, Galileo continued his research, most notably on mechanics and motion, culminating in his 1638 work Discourses and Mathematical Demonstrations relating to two new sciences. In this book, Galileo laid the foundations for the study of dynamics and the laws of motion, concepts that would later be formalized by Isaac Newton. Although Galileo could no longer travel or lecture freely, his mind remained sharp, and he continued to correspond with scholars throughout Europe, providing insights and guidance from his remote location. Galileo's death occurred just a year after the death of his contemporary, the great English philosopher and mathematician Francis Bacon. And just as the scientific revolution was beginning to take deeper root across Europe. Despite the Church's censure of Galileo, his ideas began to gradually win acceptance among scientists. His observations, particularly those made with the telescope, had exposed undeniable truths about the cosmos that were difficult to ignore. His advocacy for a scientific method rooted in empirical evidence and mathematical reasoning inspired countless other researchers, including Johannes Kepler and Isaac Newton. Kepler, who had developed the laws of planetary motion, and Newton, who formulated the laws of motion and universal gravitation, both acknowledged Galileo's influence on their own work. Without Galileo's pioneering methods and discoveries, the later advancements in physics and astronomy may not have been possible. However, Galileo's full recognition and posthumous reputation took decades to develop. During his life, the Church remained steadfast in its opposition to his support for the heliocentric theory. Even after his death, it took the Church centuries to officially acknowledge its mistake. It wasn't until 1992 that the Vatican formally cleared Galileo of heresy, with Pope John Paul II issuing an apology for the Inquisition's actions against him. The acknowledgement of Galileo's contributions by the Church came as part of a broader reflection on the Church's relationship with science. Galileo's legacy also extended beyond the academic and scientific communities. His public confrontations with the Catholic Church turned him into a symbol of the struggle for intellectual freedom, and his works became emblematic of the broader conflict between scientific progress and religious authority. His willingness to stand firm in the face of persecution and his commitment to seeking the truth through observation rather than accepting doctrine without question made him an icon of the scientific revolution and a martyr for the cause of scientific inquiry. In recognition of his enduring impact, many institutions and landmarks have been named in his honor, such as the Galileo spacecraft, which was launched by NASA in 1989 to explore Jupiter and its moons, and the Galileo mission to the moon, among others. His name is also synonymous with the scientific method itself, one rooted in experimentation, observation, and rigorous reasoning. Today, Galileo is remembered not only as a brilliant scientist and inventor, but also as a symbol of the power of curiosity and critical thinking. His ability to challenge established dogma, to persist despite enormous personal and professional challenges, and to provide the foundation for modern science makes him one of the most important figures in the history of human thought. His life and work exemplify the ongoing pursuit of knowledge and truth, reminding us that science, with its emphasis on observation, questioning, and testing, continues to shape and deepen our understanding of the universe. In conclusion, Galileo Galilei's life and legacy embody the essence of scientific discovery and the enduring human spirit of inquiry. From his early fascination with mathematics and physics to his revolutionary work in astronomy and mechanics, Galileo reshaped how we view the universe. Despite facing intense opposition, including persecution by the Catholic Church, he remained steadfast in his commitment to uncovering the truth through observation and experimentation. His contribution, Galileo's advocacy for the scientific method, rooted in evidence, experimentation, and rational thought, changed the very way we approach the world around us. Today, Galileo's legacy continues to resonate. He is remembered not only for his groundbreaking discoveries, but also for his courage in the face of adversity and his unwavering belief in the power of knowledge. His story is a reminder that the pursuit of truth, no matter how challenging, is worth the struggle. Galileo's vision opened the door to the modern scientific revolution, and his work remains a guiding light for those who dare to ask questions, seek understanding, and look beyond the horizon. Let us honor his memory by continuing to explore, question, and push the boundaries of human knowledge, just as Galileo did centuries ago.